my name is Margie Brenner, and I work at the Wind Energy Center at University of Massachusetts Amherst. Today, we're speaking with faculty member Dr. Matthew Lackner. Professor Lackner is a professor of mechanical engineering and the director of the Wind Energy Center at the University of Massachusetts Amherst. He received his BSc in mechanical and aerospace engineering from Princeton in 2002, and his Master's of Science in Aeronautics and Astronautics from MIT in 2004, and his PhD in mechanical engineering from UMass Amherst in 2007. After graduating, Dr. Lackner was appointed to a postdoctoral researcher at the Technical University of Delft in the Netherlands. He joined the UMass Amherst faculty in January of 2009. His research focuses on the aerodynamics and structural control of floating offshore wind turbines. Professor Lackner is the director of the NSF Fund Elevate program, which is a PhD program focused on solving the technical, socioeconomic, and climate challenges in the energy transition. Thanks for speaking with us today, Professor Lackner.
So I was doing my master's at MIT, and I was in a gas turbine engine research lab. And it was really interesting. Gas turbine engines are incredibly cool devices. But at that time, I took a class kind of on a whim on sustainable energy, and just became totally hooked on energy as a whole. And I started to focus on wind energy specifically because, given my background, gas turbine engines have blades and spin, and wind turbines have blades and spin. And so it seemed like a good fit for what I knew. And I started to look around for where to study and do research on wind energy. I was hoping to stay at MIT, but then I realized actually that UMass had the oldest and most well-known wind energy program in the country. And so I was lucky enough to come here to do my PhD once I finished my master's at MIT. I teach everything from freshmen to graduate students. I've taught computer programming for engineers, thermodynamics, fluid dynamics for graduate students, but I've, in the area of wind energy, I've taught our intro engineering wind energy class, which is mostly seniors, where we cover everything from the wind to blades, aerodynamics, structures, controls, electrical systems, environmental impacts, etc. And that's a really fun class to teach. And then I also developed a class on wind turbine design, which I've taught several times. And that's more of an in-depth look at how turbines, in particular the blades, but also the towers and other components are designed. And we have the students learn how to use a really powerful wind turbine analysis software program called FAST or OpenFast to be able to do that design. And more recently, two colleagues and I developed an online class which teaches people, in particular professionals, but also researchers, how to actually just run OpenFast. I think definitely working with students is the most rewarding part. It's funny, when I got hired, I had never taught a class before, and the research was really my passion. But I've come to really love teaching. I'm on sabbatical this semester, and I found I've gotten a little antsy, so I'm excited to get back to teaching. But I really, I love working with UMass undergrad students. They're really hardworking and just smart, bright, good kids. And then I love our graduate students as well. I think one of the great things about being at UMass Amherst is we're so well known for wind energy that really great applicants, graduate student applicants, come knocking at our door. And so I've been lucky enough to work with just really stellar young men and women doing their master's and PhD here. And so for me, like, the most satisfying thing is when one of my students defends their PhD and their knowledge in their domain around their topic far exceeds mine at that point. And they've become, a true world leader, an expert in that specific area. And that's pretty fantastic. The thing I'm most enjoying right now is what we're calling the wind trawler. It's an idea a friend of mine at NREL had mentioned 5 or 6 years ago, and Professor Jim Manuel, who was my PhD advisor and now my colleague, and I got interested in. And we have a student, Aaron Annan, who's been working on it now for probably 4 years or so. At first, we thought it was a bit of a crazy idea. It's basically a floating offshore wind turbine, but it's unmoored, so it's mobile, and it can basically sail the seas. So it's, I like to joke that it's like a floating wind turbine and a boat have a baby, and its offspring is this this system. And instead of making electricity, it makes hydrogen or ammonia because, of course, it's not electrically connected to the grid. But what's cool about it is it can go to the windiest places in the world, which is far offshore. And you really just can't access those resources with traditional offshore wind, whether floating or fixed. So this wind trawler sails out and fills itself up with ammonia or hydrogen, and then could sail to some collection station or meet a collection vessel, or there's different models of how it could work. But there's some real advantages. The ability to access really high wind speeds. You don't need moorings and anchors and electrical interconnections, which are really, really expensive for floating turbines. And also, especially in the past few years, it's become clear that to really succeed in the energy transition, we need tons of renewable electricity, but we also need to make various types of renewable carbon-free fuels, basically fuels made from carbon-free energy. To do things like aviation, long-haul shipping, container ships, making fertilizer for crops, different industrial processes like making steel. These things can't really be electrified. And so we're going to need fuels that are made renewably or carbon-free. And so I think this wind trawler idea fits into that bigger picture of overall decarbonization. Obviously, I think, in the US, we need large commercial scale offshore wind farms, hopefully by next summer installed. I'm really interested to see where floating wind goes in the next 10 years. That's been a research passion of mine for over 10 years now. And there's certain areas where fixed bottom makes no sense, the water's too deep and you need floating. And floating's come a long way. There've been a lot of demonstration projects and some small commercial projects in Europe. And so I'm hopeful that in particular, like California, Oregon, Hawaii, et cetera, there'll be some floating wind farms in the coming decade. And then I have just a general sort of interest in how big wind turbines will get. They keep getting bigger and bigger, faster than I expected, and I think that most people expected, and they're so enormous now, and yet the trend doesn't seem to be slowing down. So I'm very curious in 5-10 years to see how long blades are, how many megawatts turbines are rated for, because they become just so astronomically big, and the engineering work to achieve that is so impressive, and I'm curious to see how that continues.